Hi, Art Wiggins here, ready to begin another season of The Art of Physics. Now, you may recall from last season's opening show, there was some commotion in the TV host business, a lot of turmoil. There's a camaraderie among us TV hosts, and... what? Hey, wait a minute here. You're not exactly the top of the minion ladder yourself, are you?
No. No.
Okay then. As I was starting to say, Stephen Colbert, Jimmy Kimmel, Conan O'Brien, and Neil deGrasse Tyson are all thriving pretty nicely. Michio Kaku is still on the radio. I was interviewed by him twice, but I still don't quite get what he's all about, nevertheless. But David Letterman and Jon Stewart have both gotten out of the business successfully. Letterman's kicking around Indianapolis, where he went to the same high school as my wife, but Jon Stewart bothers me. Here's what he said last fall, quoted in People magazine. I'll quote it to you. I would consider getting in a rocket and going to another planet, because clearly this planet's gone bonkers. Now, I certainly respect and enjoy Jon Stewart, but isn't he infringing a little bit on our scientific territory here with this talk about other planets and going there and all that other stuff? So anyway, just the other day, my friend Kris Petrov and I were talking about other planets, and so he came to the show today to talk. Kris, nice to have you here.
Thank you for having me. Always a pleasure.
Well, last month, you were telling me about something or other you had read.
Yeah, I actually heard something on the radio about scientists discovering exoplanets in the local solar systems, and I took an interest in it, and I went to check it up online, and I guess the new data they have received basically doubles the previous estimations of how many planets were out there, and even just in our Milky Way galaxy.
Yeah, you're absolutely right. That was NASA. NASA has been doing a lot of good stuff. They're using the Kepler Space Telescope. So did you read about how they went about doing this?
Yes, I did. I guess what they do is they measure the brightness of a star, and every time there's a dip in the brightness, that indicates a planet crossing across from the sun and blocking some of the light. And that's exactly what they were looking for.
Perfect. Yeah, you're absolutely right. Technically, this is called a transit. And interestingly enough, just last month, we on Earth, we were able to get the transit of the sun by the planet Mercury. Of course, you can't see that yourself without a special space telescope. But nevertheless, here's what you would have seen. In fact, you can look at it right there on the monitor.
That's pretty interesting.
Isn't that wild? You see the path of that thing as it goes?
Right.
So it dims the sun's light a little bit.
Yes, and that's exactly what they saw. I assume some people have some pretty sophisticated home equipment, but even they probably saw mostly clouds.
Yeah, I'm afraid you're right. That's the big problem with ground-based telescopes, as a matter of fact. But not with Kepler, because Kepler, let's have a look at what Kepler looks like. I think we have a picture of that too. There's Kepler for you.
That's a sophisticated piece of equipment.
Yeah, it sure is. It's actually been in orbit since 2009.
So what exactly is position? I don't think it orbits Earth, is it?
No, not at all. No, Earth orbit is not for Kepler. Kepler is actually in orbit around the sun. It follows the Earth slightly, and so they're both going around the sun.
In the same orbit?
Yes. Yes, exactly. And so we're pretty close in that sense.
So do we know where it's pointed at?
Yeah, this Kepler Space Telescope has a 4.6 foot diameter mirror. Is that 4.6 feet?
That is pretty big.
Yeah, right. And that has that mirror, and it's pointed out there into space, and it has a field of view that has 145,000 stars in it.
Holy.
So that's how many they monitor.
That's a lot. Now, I know that to require the data that they need to estimate how many planets, they have to collect data for weeks, sometimes months at a time.
Oh yeah, it takes a long time to do that.
And you don't want anything interfering with their data, so I guess it's pointed in such a way so that Earth and the Sun don't get in the field of view, or Mars for that matter.
Yeah, exactly. The stars are in the northern constellations Cygnus, Lyra, and Draco. And Kepler's pointed right at those, and it never sees the Earth or the Sun or Mars or anything close by. So they've chosen that very carefully to avoid exactly that problem.
It has to be in a particular angle, though, because if you miss that angle, you will miss the Earth crossing across the planets crossing from the other stars, and miss the whole point of the exercise.
Absolutely right, and that's why we don't see that transit of Mercury every year, because not every year are we in exactly the right place to see that. So we are now, and so in fact the way the solar system works is kind of like a pancake. That is, the planets are in this kind of singular plane, pretty much, and that orbit the sun. So if you're looking at it from somewhere else, you got to be looking along that plane, because if you don't look along that plane, you're not going to see very much.
And if they're not perfectly aligned, we'll miss a lot of those.
Right. So they only get to see some. So.
Right.
In fact, for that matter, if you think about what Kepler looks at, they see an area about the size of two Big Dippers. You know the Big Dipper in the sky that points at the pointer stars that point at the North Star, Polaris? About two of those dipper sizes is all they see.
That's all they see.
So they're seeing this little patch, and in this little patch they see 145,000 stars that they monitor for transits.
And even from that small observable area, they still find a lot of planets. I think the number was something like 2,325 or something like that.
They saw that many planets.
Wow.
Absolutely right. Those planets were visible, and so I think Kepler has just been doing a heck of a good job. So you might even wonder how many planets are there in the entire Milky Way, not just those two little dipperfuls.
How many?
The answer is 40 billion.
40 billion.
40 billion. If you started counting them one planet at a second, it would take you more than 1,000 years to count them all.
That is an insane amount of planets. And that's not considering the rest of the universe. You know, from last estimation, I hear it's something between 100 billion and 200 billion galaxies.
Right. And of course, now we're out of our salary range because we don't get the numbers that big very often.
So you would assume that not all planets are Earth-like planets that they discovered.
No, not at all. Some are too hot, some are too cold, some are too big, some are too small.
Right, and that's what they call that, the Goldilocks problem?
Goldilocks. Yeah, Goldilocks. Wasn't Goldilocks try the bear's porridge, and the one bear's porridge was too hot and the other was too cold, and the other is just right. Well, the Earth is just right. We are just in the right zone. It's not too hot, not too cold. Our sun is not too big, not too small. Everything works out pretty nicely for us. So in fact, there was a way of doing this that they started thinking about in 1961. In 1961, an astronomer whose name was Frank Drake formulated an equation for how to estimate this. Can we see Frank Drake? There's Frank Drake. He's got this big fancy equation. But it's a bunch of baloney because it's just a bunch of factors, and we don't know what the real values are of any of the factors. But at least it points to what the possibilities are. So anyway, that's Frank Drake.
Just to go back to the data they got from Kepler, out of the 40 billion stars, how many do they estimate are orbiting sun-like stars that are in the Goldilocks area where it can support life?
That's about 11 billion only.
11 billion.
11 billion.
Only.
Only. And the nearest one is 12 light years away.
11 billion, wow. That seems far away, but you know, with 11 billion, you have to assume that some of them will support life. And yet we haven't heard from any extraterrestrials at all. So what's up with that?
You sound so much like one of my favorite physicists whose name is Enrico Fermi. Enrico Fermi used to go to lunch with his colleagues, and he would pose questions to them to think about. And one of his questions was, if there are so many extraterrestrials, how come we don't see any of them? Where are they?
Right, so where are they? What is the problem?
Don't you wonder? Among the scientific community, the opinions are all over the map. That is, there are some people that say, oh, there's only one with intelligent life, us, that's it, Earth. And others that say, no, there are millions, maybe billions of intelligent life forms out there. We just haven't seen them yet. So here's the big problem. There's two problems, really. One is distance and the other is time. That is, if the nearest one is 12 light years away, that's the nearest. But suppose the first one that has any intelligent life is probably more like 1,000 light years away. So it's 1,000 light years away.
And we're not even nowhere near close to the speed of light as far as travel.
No, traveling is going to be really tough. But even if you sent a signal out there and said, well, let's have a little conversation with these extraterrestrials.
It will take 1,000 years.
Yeah, so you say, hello, into your microphone. 1,000 years it travels, it gets out to them. They hear it, they say, hello back to you. 2,000 years now. So you and I aren't going to be hearing that very much unless life gets lengthened more than we imagine. Right. So,
well, statistically speaking, out of 11 billion stars, you have to assume that there's something out there. What do you think?
Oh yeah, I think so. I think there's stuff out there. I'm not sure where we're ever going to find them because our rockets are just not fast enough at this point.
Well, waiting for that signal to come back, it's almost like getting those robocalls with political causes. You pick up the phone and there's a silence on the other side until the machine kicks in and they try to throw their sales pitch, ask you for money, for donations. You know, I don't think that Jon Stewart was looking for a planet with life on it per se to move to.
No, in fact, I really wonder at some of the life on this planet that I think he was objecting to. So I got an idea though, Kris. You know, you're familiar with the way the web works, and they have these GoFundMe websites.
Right, I heard about that.
Yeah, so maybe what we ought to do is we'll start a GoFundMe page, and we'll see if we can raise a lot of money so that we can send Jon Stewart. Do you think there are other people that would like
There's a lot of people that also mentioned that if that particular politician gets elected, they would like to leave Earth.
So maybe then, well, I guess we'd have to raise a lot of money. In fact, can you imagine? Let's see, I think there's a SpaceX that, let's see if there's a launch of the SpaceX that we can look at, because that's what we would have to fund, would be the SpaceX rocket.
That's pretty cool picture.
Oh yeah, well, I'll tell you, that's the SpaceX rocket, and it'll get there.
That's a privately funded company, right?
Privately funded. Elon Musk, I think, is the guy behind it.
And he's also the guy behind Tesla?
Yeah, I think so, yeah. So all it would take then is, well, if we're going to have to make a pretty big one, I suppose. In fact, with all the people who would like to escape this one politician, I think it would have to be huge.
Huge rocket?
Yeah.
That's pretty huge. I have a better idea. How about we build a small enough rocket for one person, take down one particular politician and ship him out of space.
Whoa!
Save us a lot of money. We'll do much better than shipping everybody else out. What do you think?
I think that's a good point. I really like that a lot. You know, the GoFundMe campaign would have to only buy one ticket, and it just has to be one way.
Right. How about we use your minions? Can they help us with that?
Oh, even better. After all, the minions set up the Scientist Protection Program, so maybe they can set up an electorate protection program.
Sounds good to me.
Wow, that would be really nice. Oh, I guess I better have to go talk to some minions about that. Kris, you're full of good ideas today. I really like this.
Thank you so much.
Thanks so much for coming on the program.
Always a pleasure.
So until next time, I'm Art Wiggins, but you know what? I got to go talk to some minions to see if maybe the minions can find a way to run this electric protection program. Hey, minion. Do you think you can do it? We'll find out. Stay tuned.